Just like solving one-step inequalities is similar to solving one-step equations, solving multi-step inequalities is pretty much the same thing as solving multi-step equations. So if you look at this example here, it says solve 5x minus 3 is greater than 12. You're going to solve it just like it said 5x minus 3 equals 12. Use your steps for solving equations. What are we solving for first? Well, remember, we're always solving for the x. So if I'm solving for x, and specifically the 5x, what do I have to get rid of first? The 3. Well, it's minus 3. How do we get rid of it? You add 3 to both sides. Bring down your 5x. Double check to make sure that these cancel. And then 12 plus 3 is 15. Now, normally we'd bring down our equal sign, but we know now that this is not an equal sign. It's an inequality, a greater than sign. So since we didn't do any multiplying or dividing yet, we don't have to worry about reversing the direction of the inequality symbol, so we can bring down our greater than sign. Keep going. What are you solving for? X. What do you have to get rid of? 5. It's 5 times x, so how do you get rid of it? By dividing. Whatever you do to one side, do to the other. 5 divided by 5 is 1x. 15 divided by 5 is 3. Before you bring down the inequality, just like with one-step equations, ask yourself, did you multiply or divide by a negative number? I did divide, but I divided by a positive. Therefore, our sign stays exactly the same. It's only if you multiply or divide by a negative number. So hopefully you can see that solving multi-step linear inequalities is going to be the same thing as solving equations for the most part. We just have to be careful when we multiply or divide by a negative number. It doesn't say to graph, but if you would wanted to graph, just to kind of remind you of how we graph. Take your number, circle on the line, decide if it's open or closed. Again, if it's just greater than or less than, it's open. If it's greater than or equal to or less than or equal to is when we fill it in. Since this is just greater than, we leave it open. And we're talking about all the values greater than 3. So we're going to draw our arrow to the right. Now you should label your line with an X because all the values on here, 3 and greater, or I'm sorry, greater than 3, are all the possible X values we can plug in. Just read your homework. If it doesn't say to graph, you don't have to. If it does ask you to graph, make sure you include this step. Let's look at a couple more examples. Look at this example here. Negative 3x plus 1 is less than 22. What are you solving for? X. So let's solve for the negative 3x first. So what do you have to get rid of first? The 1. How do you get rid of it? Since it's plus 1, we minus 1. And whatever we do to one side of the inequality, do to the other. Bring down your negative 3x. Double check to make sure those cancel. Bring down your inequality because we didn't do any multiplying or dividing yet, so we don't have to be worried about that. 22 minus 1 is 21. Now, what are we solving for? X. What do we have to get rid of? Negative 3. It's negative 3 times x, so how do we get rid of it? Well, we divide by a negative 3. And again, we divide by a negative 3 because that means these negative 3's will cancel out. If you divide the left side by a negative 3, divide the right side by a negative 3. Negative 3 divided by negative 3 is 1x. 21 divided by a negative 3 is going to be a negative 7. Now before you bring down the inequality, did you multiply or divide by a negative number? Yes, you did. You divided both sides by a negative 3. So if I divide both sides by a negative 3, all I do is I flip the inequality over. Instead of saying less than, it becomes greater than. Our directions don't say to graph here, so I'm going to move on. Look at this equation here. We have negative x plus 1 is less than or equal to 3x plus 21. Remember, treat it just like if it was an equation. If you want, you can put a 1 in here and say that this is negative 1x. But our problem right now is that we have x's on both sides. So let's get them all to one side. You can move either x. You can get rid of the negative 1x by adding 1x to each side. You can get rid of the 3x by subtracting 3x from each side. With inequalities, I like having the variables on the left side. So even though it might work out the numbers a little easier to add 1 to each side, I'm going to get rid of the 3x. I get rid of it by subtracting it from each side. Notice what happens. Negative 1x plus a negative 3x is a negative 4x. Bring down your 1. Oops. Don't forget your plus sign. Bring down your plus sign because plus 1. Actually, let me write this a little bit better here. negative 3x plus 1. I haven't done any multiplying or dividing, so I can bring down my inequality symbol. I'm going to double check to make sure those cancel, and then I'll bring down my 21. Now I'm just solving a regular two-step inequality. I'll subtract 1 from each side, bring down my negative 4x, these cancel, bring down my inequality symbol, 21 minus 1 is 20, and then I'm going to divide each side by negative 4. Negative 4 divided by negative 4 is 1x, 20 divided by negative 4 is a negative 5. Because I divided by a negative 4, don't forget to reverse the direction of your inequality. Just flip it over. Solving multi-step inequalities is again pretty much the exact same way you've solved regular multi-step equations. Just again, be careful that you flip the inequality only when you multiply or divide by a negative number.